Alright, in this video goes with the crash course of adding and subtracting fractions. We're going to be talking about just that, how to add, subtract fractions. So in the workbook, first comes a review. So in this first video, I'm going to go through the review section of the workbook. I'm going to do all of these examples, the mixed and improper fraction part. Alright? And then adding and subtracting fractions with like denominators will be on the next video. Okay, so let's go to the first set of questions, and that would be on, let's see here, the third page of the booklet. You'll see that there are three, okay? Now it says for both represent the same part and whole portion in as if you were reducing to 2/4, you would get 1/2. So basically we're doing what is modeled right here for each one of these. Hold on. I think my daughter was playing with my pen. So for the first one, yep, she most definitely was playing. Everything needs reoriented. Just give me 1 second and we'll try this again. So for this first one, this number 2, I'm going to use the whole space to model it, okay? So to model it first, the bottom part of the fraction tells me the whole parts that make one whole thing. So in this one, it's 14. 2, 4, 6, 8, 10, 12, 14. Oh, that's what I needed. Okay, let me make sure this is right. 2, 4, 6, 8, 10, 12, 14. And this tells me, this top part tells me the part that is shaded in. So I have 10 shaded in. There's 2, 3, actually let me change the color on this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? And it tells me let's reduce this fraction by giving the reduced part in whole. Well, if you did it mathematically, you said, oh, well, these are both divisible by 2. I'm going to reduce by 2's. Now I have something that is 7 pieces. Three, 4, 5, 6, and 7, and 5 of them are colored in. 3, 4, 5. And if I had drawn this one a slightly different way, it would have showed the same thing. It would have showed the same lines. Another way that I could have approached this problem was said, what line do all the blocks share? And they all share this middle line. This middle line is going through all of them. And if I were to take that shared thing that they have out, I'd have 1, 2, 3, 4, 5, 6, 7 blocks, and 1, 2, 3, 4, 5 would have been colored in. Alright, so let's try another one. I want to keep that reduced fraction. Alright, so the whole point of this modeling is to get these reduced down. Both 5 and 15 are divisible by 5. Okay, which is going to give me a 1 and a 3. Okay, because I'm dividing both top and bottom by 5. Whatever I do to one, I have to do to the other. Alright, so if I was going to write this, model it, It would be this. Now look at something very interesting. So we're saying if I were to put these into factor trees, it would be 1 times 5, and it would be 15 would be 5 times 3, and we're saying that their common factor are the 5's, which leaves us with the 1 and the 3 as our new fraction. Okay, so when I model this 15, I do 5. There are 5 going up and 3 columns going over. So look, it is 5 times 3. That makes the amount, the 15 squares in our model. And I have 5 of them colored in. So 1, 2, well, let's just do this whole column. All right. So look at that. That is 1/3 of the picture. If I look at the 3 columns, 1/3 of the columns, 1 out of the 3 columns is completely covered, filled in. And that's our 1/3. And what I really want for you to get is this fluency of numbers, of how they sort of intertwine. Okay? So if I were to make that one full thing, I have, if I wanted to do the 1/3, there's 3 columns and 1 whole column is filled in. So that would be the matching effect. Take out all these lines. All right. Okay, so this next one is an improper fraction, but let's reduce it down. I can tell that both numbers are divisible by 3. So that is 4 over 3, which is 1 and 1/3. So let's go ahead and do this one. So the bottom still means how many. This one I have to fill in 4. Well, I only have 3, so I'm going to fill in the 3. Then I got to build another box of 3 and fill in one of them. So I have 3 boxes. So that shows a whole 1 and 1/3. Okay? Which was our 1 at the end. Alright, if I were to reduce this one, it's divisible by 3's, which is 1/4. And if I want to make that 3/12, I would have to cut this into 4ths, because that would be 1, 2, 3, 4. Oh, wait a minute, I messed that up. Sorry. Cut it into thirds. I was right the first time. I went one line too many. Okay, because that would be 1, 2, 3, 4 times 3, which would 4 times 3 gives me the 12 I need. So that means there's 12 squares in here. And now 3 are automatically colored in because it was 1/4, and that whole line that I just split into 3 was colored in. So you see how that fluency works both ways? That's what I really want you to get. All right, let's look at some mixed and improper fractions. So in this, if I go down to the now you try, you'll see that I have 6 questions where I have to turn these numbers into improper or mixed numbers. So first I'm going to go around and label them. A mixed number means it's a mix of a whole number and a fraction apart. This one is improper. We call it improper because the top is bigger than the bottom. Okay, this is also a mixed. This is improper. This is mixed. And this is improper. So now I'm going to turn it into the other one. So if this one's mixed, I'm turning it into improper. So this is how I want you to think about it. The whole number tells me how many whole parts I have. The number on the top tells me the part that's left over that I didn't use to make a whole part, and 5 tells me how many I need to make a whole. Alright, so this is saying, I'm going to use Skittles, that 5 Skittles make a bag of Skittles. I was able to make 4 bags of Skittles with 3 left over. So if I cut open all 4 of these bags and dump them out, I'm going to have 4 bags of 5 Skittles. And then I'm going to have 3 leftover Skittles. So if I go ahead and do that addition, that's 5 plus 5 is 10, plus 5 more is 15, plus 5 more is 20, plus the 3 is going to be 23. Now this part is repetitive addition if I added them all together. Repetitive addition can turn into multiplication. So I can say I have 4 pieces times 5 pieces in each, 4 bags, 5 pieces in each bag plus the 3 left over. Look, that's our original numbers. So I just multiply the whole number by the whole part of the, or the denominator of the fraction, plus the part or the numerator of the fraction. All right, to get our new numerator, and the bottom always says 5 because it still is 5 Skittles that make 1 bag. All right, so the next one is improper, and I want to turn it into mixed. Well, to do that, there are 2 ways I can go about it. I can first either model it or I can divide it. So first let's model it and then we'll figure out a mathematical solution. So I'm going to draw my 34 Skittles. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, and 34. And it says that this is how many Skittles I have, and that 5 Skittles go in a bag. So I'm going to make bags of Skittles. So there's my first bag of Skittles. Here's my second bag of Skittles, third, fourth, fifth, and sixth. I was able to make 6 bags of Skittles with 4 Skittles that I couldn't get into a bag because I didn't have enough. So it's 6 4/5. Now, like I said, there's another way to work this particular problem out, and that is through dividing. I could have divided the 2, okay, and I think that maybe I should give myself a little bit more room. I could have divided the 2 and said 34 with 5 divided into it. 5 goes into 34 6 times, which is 30. Drop down my 4. This is my whole number. This is my part, the part that's left over, or the numerator. And this is the denominator, or the whole amount that makes 1. Okay? Let's go ahead and do number 3, and then I'll erase. Okay, so number 3 is a mix, and I need to turn it into improper. Now remember, I can either model it. I have 2 bags of Skittles with 9, and then 4 left over that didn't go anywhere. So I could add this up and get 22 total. 22 over 9, the denominator never changes. Or I could say, well, if I have 2 bags and there's 9 in each, that's repetitive addition or multiplication plus the 4. 18 plus 4, 22 over 9. Both are the same way. All right, so let's go ahead and erase some of this. We have 3 more to do, 2 impropers and a mixed. And let's get started. Alright, so now we're doing number 4. Number 4 is an improper. We got to make it a mixed number. And remember, we can either model that by drawing out our 52 pieces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, and 52. Alright. And if I make them into bags, there's 7. There's a bag of Skittles. 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 Another one. Another one. And I can't make one out of this one because I don't have 7 more. So 1, 2, 3, 4, 5, 6, 7. Can make 7 full bags with 3 7ths left over. The denominator always follows through. Okay. Now I could do that also by division. So I have to ask myself, how many times can 7 go into 52? Okay, so 7 can go into 52 7 times, which would be 49, leaving me with 3 extra. This is the numerator, this is the denominator, this is my whole number. So I'd get the same answer both ways, 7 and 3/7. All right, let's turn this mixed number into a improper. So in this one I have 7 bags of Skittles, and each Skittle bag has 6 in it. But that's not all I have. I also have 5 Skittles that didn't end up in a bag. Okay, so 6 plus 6 is 12, plus 6 more is 18, plus another 6 is 24, then 30, 36, and the last one would be 42, plus 5, so 47 over 6. Well, I can also get that by saying 7 times 6 plus 5, which is basically what I did. Multiply these two, add these two, and I would get 42 plus 5, which is 47 over 6. Very good. One more. And it's an improper one. And then that's it for this particular video. Alright, so to turn this into 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, that's 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 40, oh, just 40. Okay, so I have 40 Skittles and 5 go in a bag. I want to change the color so it pops. So here's 6. So now you see why I put them in rows of 6. It makes it a little bit easier to make my bags of Skittles. And it looks like I can make 5 bags of Skittles. So my fraction is 5 bags of Skittles, and I have 1, 2, 3, 4 left over, 4 out of 6. Well, some of you might have said, hey, I can reduce that. I know how to do that. They're both divisible by 2, which will give me 5, and 2 goes into 4 2 times, 2 goes into 6 3 times. So depending on where you are in math, it can be either of those two. Another way I can solve this is by dividing. 6 goes into 40 6 times, which is 36, leaving me with 4. This is my part or numerator. This is my denominator or whole, and this is whole number. I said 6, but I wrote 5. Sometimes I goof. Sometimes I say it, but my brain is working on something else in my head, and I write the wrong thing. It's called mommy brain. Alright, so watch this again and again until you feel like you got it. On the next video, I'll go over the next part of the workbook, which is the adding and subtracting like denominators, before I get to this next part, which is unlike denominators. So I'll be doing example, I think it starts out 1, because this is the actual class, what I went over. So the first 15 examples will be in the next video. And then in the last video, well, I don't know if it's the last video, I'll do 16 through 22, and then there is one more where we borrow. Okay. So I hope that was informative. Let me know if you have any questions, and I hope to see you in more of my OutSchool classes.